Dara, Liam, Suki, how much does your building weigh?
Sure. Well, I was hoping for Dara to give a bit of context around the question, how much does your building weigh? But I can, what I'll do is I'll share a little bit more around less of the context, even though it's a very interesting anecdote and the story is interesting and one that should be shared, but more actually about how that actually allowed us to consider granular BIM approach that delivers process and what we've done on the BOHM side is we're really thinking about how can a product house that process. And ultimately, we have a hypothesis, and you can learn more about that through the white paper titled How Much Does Your Building Weigh? That actually allows for hypergranular. We believe that hypergranular is the route to putting construction and architecture on the blockchain. And why that's important is because it's kind of a secure and safe way to manage the risk that Gareth's been highlighting. But also when we have these kind of hypergranular independent parts of a building, they hold tremendous amounts of metadata that, can essentially, like, you can take those parts and they can automate specifications of the builds, schedules, sequencing. And when you have that kind of much automation and kind of optimal programming around all of that, and with all that metadata kind of being held in those parts, and understanding things like was it correctly specified for strength, or was the metal type properly specified? Is it possible to install the fixing, like its buildability, and all of these questions are able to be answered through this hypergranular approach, which when we're being provocative, the how much does your building weigh, we felt that was a fun way to tease it, because it goes back to Buckminster Fuller and some work that he was doing with Norman Foster. And I wonder if we're at a point potentially where we're able to show a little bit about what that hypergranular approach looks like.
My name's Dara Khera, and I have been an architectural designer and been working in the field of BIM and virtual design for construction for the last 20 years, and trying to get the promise of BIM to work and how we can bring together all elements to have a practical impact on the built environment, an immediate and practical impact. BIM's been around in the marketplace for about 20 years, a little bit longer. In fact, it started in 82. And what we've seen in our journey is trying to use it and apply it in a way where we see those promises come true. And the reason why it's important to us is that the waste, or the question that Gareth started with, which is how much does your building weigh? Well, your building weighs everything that is left at a result at the end when it's built, but also all the waste, all the excavation, everything like that, and the design time and the human resource that's there. So I'm going to start playing a video to try and explain to you how we look at that and how that comes across. So hopefully the screen is working and you'll be seeing a little bit of what we do. So we model everything at a hypergranular level in 3D. And by doing this, the effect that we have is that nothing turns up on screen, nothing turns up on site that shouldn't be there in the first place. So in showing you this model, what we're showing is that this isn't a composite or a surface model. Every element in this model, down to the last nut and bolt, has been modeled and can be commodified. And therefore, we cut down the waste on site immediately. So whether it's a piece of timber or whether it's a screw, we know exactly how many need to be there. And the process for us starts with completing the design to a high level before you start construction. By completing the design before you start construction, you have a kit of parts. IKEA, if you like, for a whole building. So nothing turns up that shouldn't be there. And in using this process, it makes life easier for everyone. So here we're looking at even a fire exit sign. You can press on it in the model and it will take you straight to the manufacturer, where it came from, where it originated. And this goes down for every element in the building. It could be a light switch like this one, and it'll tell you who made it, where did it came from, where it came from. It sets a perfect bill of quantities for that to be ordered also. And in doing this, we have a practical and immediate effect on sustainability. And we've seen it firsthand how much is wasted, not only in the design process, but in the construction process. And we know this because we see the skips leaving the site every week. When you get to a level of hypergranular, everything is accounted for. And not only that, the workmen who work on the building, they all have the model on their iPads or on their phones. So they can see exactly how the pieces that we order fit together in context of the building. So we move away from 2D to 3D, and in that process, we reduce waste almost immediately. And you find the gains everywhere. The productivity rises, the number of people you need on site comes down. The amount of waste is reduced to almost zero. What we find is we just have packing materials. So the version of this model that you saw earlier, it's the same model, this is just a different model view. We're going into a finished view, and you had a structural view earlier. And in this finished view, you can see that even a tile on this fountain outside, each tile is processed. So we know the color, the supplier, the mitered edges. As you go through the building, if it's a tap, simply in a case study for an O&M, you have a digital O&M, and it'll take you straight to who made the tap, where it came from, and the history of it. And you can have all of that as a simple model delivered to the client at the end. They'll go for a light fitting the same. So if somebody had to come in and change the light fitting, they'd simply press on the model in their iPad on the phone. It would take them directly to the site of the manufacturer and instructions on how that light fitting might be changed. And that carries out through every element of the building. So all the information to do with the building and how it's put together is in one simple model, and that one simple model is available to all the stakeholders, including a perfect list of the quantities in a model. So if you want to know where any particular part is, you can ask it to show you. So this is a very innocuous underground drainage pipe, but you can locate it, you can account for it. And in doing so, it just establishes that nothing that isn't required for your building turns up. So the weight of your building, to answer the question, is exactly what it should be, as it was designed, no more, no less. What you're seeing here now on screen is the number of drawings that it takes to make a building. And all of these drawings have been automated and generated from the model. Normally, this level of information and this number of drawings would take maybe a small army of people to produce. All the information here was produced by one person, creating the model, and then the rest of the team putting in quantities and so on. So in essence, the model took perhaps a maximum of 2 people, but all the information was produced in half the time and at half the cost that you might otherwise expect. And it generates a very, very high quality of information for the entire team. So whether it's building control, the constructor, the MEP engineer, the structural engineer, all of that information is fully coordinated and available in one place. And that's what the future of decarbonized environment, before we get to, making cement-free cement, if you like, or concrete. These are steps that can be taken today. And the amount of waste and cost that occurs in a building can be dealt with immediately if we learn simple processes of completing the design before we start building. And too often we see it the other way. And that is that you continue designing through the build phase. And that is inefficient, very expensive, and at a huge cost to the environment. So what we're trying to display here is that the technology, or the promise that technology brings together in one source of truth and can be used by the entire team. And at the end, when the building is built, you can still use that model to run and to manage its life cycle costs. Here in the image, we're just showing how much information can be embedded within one model. And that can be the carbon. What is the carbon of the part? Where did the part originate? Who specified strategy of that part? Essentially, any information you want to put in, we're pretty much proving you can put it into a single model. And we believe that that is what's needed for an immediate and pragmatic effect. That's available for every building that's going to be built in the UK or indeed globally. And it's a practical application. I believe that technology happens quickly. And once those gateways are open, we should see that happening more and more often. And yeah, I think that's what I can tell you about the model and how we are tackling it at work and at BOHM.